Joint probability distributions. If x and y are two discrete random variables, the joint probability function of x and y is p of x equal to x, comma y equal to y. That is, whenever the random variable capital X takes this value, and when the random variable capital Y takes this value, then this particular probability is denoted by f of x comma y. And f of x y should satisfy these conditions, that is, where f of x comma y should be greater than or equal to 0, that is, every probability must be greater than or equal to 0, and double summation, that is, first summation over x, second summation over y, f of x comma y should be equal to 1. That is, total probability must be equal to 1. Here, if you consider f of x1, f of x2, and so on, f of xm, these are the sum of horizontal entries, and g of y1, g of y2, etc. up to g of yn are the sum of vertical entries in the joint probability distribution table. We will see this in detail when we are solving the problems. These are called marginal probability distributions of x and y respectively. Then we have few problems. Expectation. Mu x is nothing but mean here. Mean of random variable x or e of x is equal to summation xi into f of xi, and mu y, that is mean of random variable y, equal to expectation of y, and that's equal to summation yj into g of yj. Mu of xy, that is expectation of x into y, that's equal to double summation xi into yj into f of xi yj. Variance. Variance is denoted by sigma square of x, and that's equal to e of x square minus e of x whole square. And sigma y square is equal to e of y square minus e of y whole square. Covariance. For covariance, the formula is covariance of random variable x and y is equal to e of xy minus e of x into e of y. Correlation of x comma y or correlation of x and y is denoted by rho of x comma y, that's equal to covariance of x comma y divided by sigma x into sigma y. Note, if x and y are independent random variables, then expectation of xy will be equal to expectation of x into expectation of y. So if x and y are independent random variables, then what will be the value of covariance? Since these two quantities will be same, covariance will be equal to 0. Since covariance value is equal to 0, the value of correlation will also be equal to 0, because this numerator will be equal to 0. Let's see a few problems. First problem. The joint probability distribution table for two random variables x and y is as follows. So these are the values taken by x, that is x takes the values 1 and 2, y takes the values -2, -1, 4, 5. Now some probabilities are listed out here. Let's see what these are. 1 minus 2, and here the value is 0.1. That means when x takes the value 1 and when y takes the value -2, the corresponding probability is 0.1, or you can even say it's something like this. Probability that x takes the value 1 and y takes the value -2, and the corresponding probability is 0.1. Similarly, when x takes the value 1, when y takes the value -1, the corresponding value is 0.2. When x is 1, y is 4, this is the value. When x is 1, y is 5, this is the value. Like that, the last value here is when x is equal to 2 and when y is equal to 5, this is the corresponding probability, and the probability is 0. Now, based on this distribution table, they have given the following questions. Determine the marginal probability distributions of x and y. Also compute expectations of x comma y and xy. Standard deviations of x and y, covariance of x and y, correlation of x and y, Further verify that x and y are dependent random variables and also find the probability that p of x plus y is greater than or equal to 0. Greater than 0. Now looking at this table or using this table, you have to get the marginal probability distributions of x and y. So to make the marginal probability distribution, what you need to know is the values which are taken by x. In this joint probability distribution table, the values taken by x are 1 and 2. So first thing which we do is we write the values taken by x, that is 1 and 2. Now f of x here denotes the probability that x takes the value 1. Now for x is equal to 1, there are 4 different probabilities here for different values of y. Because when x is equal to 1, y can take the value -2 or -1 or +4 or +5. So please note, if you want to calculate the probability that x takes the value 1, you will have to add these 4 probabilities here, because when x is equal to 1, y can take any value in this range. So when x is equal to 1, the corresponding probability value is 0.1 plus 0.2, that is 0.3, 0.3 plus 0.3, that is 0.6. Then now what we have to calculate is we have to find the probability that x takes the value 2. When x is equal to 2, y can take the value -2 or -1 or 4 or 5. So there are 4 cases possible for x to take the value 2. So how do you get the corresponding probability here? 0.2 plus 0.1 plus 0.1. So that is 0.3 plus 0.1, 0.4. Now here you can see that if you add the probability values here, 0.6 plus 0.4, total probability is 1. So this is the marginal distribution of x. Now similarly, let's find the marginal distribution of y. To do that, we'll have to consider all the different values taken by y. So here y takes the values -2, -1, +4 and +5. So if you want to find out the marginal distribution table for y, you have to take -2, then you have to take -1, then here +4, and the last value is +5. Now let's see how do we get the probabilities here. So when y is equal to -2, x can take 2 different values. It can take the value 1 or it can take the value 2. So if you want to calculate the probability that y takes the value -2, that corresponding probability will be 0.1 plus 0.2, because this column belongs to the column where y is taking the value -2. So 0.1 plus 0.2, the first value here will be 0.3. Now the next value for y is equal to -1, again it will be 0.3. Then for y is equal to 4, 0 plus 0.1, that is 0.1, and for the last one it will be 0.3. So you get 0.1 and here you get 0.3. Let's add the probabilities and check. 0.3 plus 0.3, that is 0.6, 0.7, 1. So here also total probability is equal to 1. Now let's calculate the values of expectations of x, y and xy. So now mu x or mean of x or expectation of x can be calculated by using this formula, that is summation x into f of x. So when x is equal to 1, the corresponding probability is 0.6. So first entry here will be 1 into 0.6 plus 2 into 0.4. That will be, this is 0.6 here, 2 into 0.4 will be 0.8. 0.8 plus 0.6, that is 1.4. Then the next value, that is summation y into g of y, that is equal to, here y takes the first value as -2, minus 2 into 0.3 plus minus 1 into 0.3 plus 4 into 0.1 plus 5 into 0.3. So if you calculate this value, you get minus 0.6 minus 0.3, that will be minus 0.9 plus 0.4 plus 0.3 into 5. So the corresponding value for E of y will be equal to 1. Now let's see the value taken by E of xy. So to find out E of xy, the formula is summation x into y into f of x comma y. So to get that answer, what we have to do is we will have to use the joint probability distribution table, because in that both the values of x and y with the corresponding probabilities are present. So now here, when x takes the value 1 and when y takes the value minus 2, the corresponding probability is 0.1. So how do you calculate that? You get 1 into minus 2, that is minus 2 into 0.1. So the first entry here will be minus 0.2. Then when x takes the value 1 and when y takes the value minus 1, the corresponding probability here is 0.2. So 1 into minus 1 into 0.2. So you get minus 0.2, the next value. After that, you have 1 into 4, that is 4, into the probability, which is 0. Here it is. Like that, if you continue, you get 1 into 5 into 0.3. Then 2 into minus 2, minus 4 into 0.2. 2 into minus 1, minus 2 into 0.1. 2 into 4, 8 into 0.1. And obviously the last value will be 2 into 5 into 0. So here are the values which we get, and E of x y will be equal to 0.9. Next thing which we calculate is variance of x, that is sigma square of x, that's equal to E of x square minus mu x square. We note that the value of mu x is already calculated. The mean of x or expectation of x, it's already calculated. Let's just find the value of E of x square. E of x square is equal to summation x square into f of x. So summation x square into f of x can be calculated equal to 1 square, which is 1 into 0.6 plus 2 square, which is 4 into 0.4. So E of x square is 1 into 0.6 plus 4 into 0.4, which is equal to 2.2. Now sigma x square is equal to 2.2 minus mu x square is already calculated earlier, that's 1.4 square. So variance of x is equal to 0.24, and if they ask you to calculate standard deviation of x, that is sigma x is equal to 0.49. To calculate that, take the square root here. Similarly, you can get the answer for sigma square y, that's equal to E of y square minus mu y square. E of y square is equal to summation y square into g of y. So now here, minus 2 square, that is 4 into 0.3 plus minus 1 square into 0.3, 4 square into 0.1 plus 5 square into 0.3. So here E of y square will be equal to 10.6, and sigma y square will be equal to E of y square, which is 10.6 minus mu y is calculated earlier, it is 1. So mu y square will be 1 square. You solve it, you get 9.6. So variance of y is here as 9.6. Then standard deviation of y will be root of 9.6, which is equal to 3.1. Then we calculate covariance of x comma y, which is equal to expectation of xy minus expectation of x into expectation of y. Expectation of xy is already calculated. it's here 0.9, and expectation of x and expectation of y is also already calculated, that is 0.9 minus 1.4 into 1, that is 1.4. So covariance is equal to minus 0.5. Earlier in the note we have already seen that if covariance is non-zero, that means x and y are dependent random variables. Next thing which we calculate is correlation of x and y, that's equal to rho of x comma y, and to calculate the value of correlation we use this formula, that is covariance of x comma y divided by sigma x into sigma y. Substitute the values here, you get the value of correlation as minus 0.3292. Next we calculate the probability of x plus y is greater than 0. So here from the given table we have to find out when the value of x plus y is greater than 0. That is, when you add the random variable x with the random variable y, that sum must be greater than 0. When is that possible? And you have to take the corresponding probability. So let's take the first case. If you take x as 1 and y as minus 2, and if you add them, the sum will be minus 1. So I can't take this case. If I take x as 1 and y as minus 1, sum will be 0. This case also cannot be considered. So which case I can consider here is when x is 1, y is equal to 4. In that case, the total or the value of x plus y is 5, and that is obviously greater than 0. So the corresponding probability will be 0. Now if you take the case when x is 1 and y is 5, then also probability is the sum 1 plus 5 is greater than 0. So the corresponding probability will be 0.3. Similarly, you will have to find out all the cases when x plus y is greater than 0. This is what you have to find. So when I have done that here, so we get these 5 different cases where the total of x and y is greater than 0. First case is 1, 4 and the corresponding probability is 0. Next case is 1, 5, total is 6, corresponding probability is 0.3. Here you have 2, minus 1, total will be 1, greater than 0. So we take this case also. This is the probability, 0.1. 2, 4 also can be considered and the probability is 0.1. 2, 5 also can be considered and the corresponding probability is 0. So the probability that p of x plus y is greater than 0 will be equal to 0.5. So please note, when you want to calculate p of x plus y greater than 0, you will have to take all those pairs x, y, so that the total of x with the total x plus y should be greater than 0. Second question, given the following joint distribution of the random variables x and y, find the corresponding marginal distribution. Also compute the covariance and correlation of the random variables x and y. So these are the different values taken by x, that is x takes the values 2, 4, 6, y takes the values 1, 3, 9. And these are all the corresponding probabilities. So now using this joint probability distribution table, you will have to make the marginal probability distributions of x and y. So as we have done in the earlier problem, first we list out all the values taken by x. X takes the values 2, 4 and 6. Now if you want to find the probability that x takes the value 2, then we have to add these 3 values, because when x is equal to 2, y can be equal to 1 or 3 or 9. So 1 by 8 plus 1 by 24 plus 1 by 12. So if you add them, you get 1 by 4. When x is equal to 4, the corresponding probability will be 1 by 4 plus 1 by 4 plus 0. So the value is 1 by 2. When x is 6, the corresponding probability will be sum of these 3 values. Probability will be 1 by 4. Similarly, we can get the marginal distribution of y. you can see that y takes these three values here, 1 or 3 or 9. And the corresponding probabilities can be obtained. For y is equal to 1, the corresponding probability will be 1 by 8 plus 1 by 4 plus 1 by 8. The value is 1 by 2. When y is 3, the corresponding probability will be this column sum. And for y equal to 9, this is the probability. That is, if you add these two values, you get the required probability. Then after this, what we are asked to calculate here is we have to find the covariance and correlation. So to find the value of covariance, this is the formula: expectation of xy minus expectation of x into expectation of y. So expectation of x here is mean of x, that's equal to summation x into f of x. So 2 into 1 by 4 plus 4 into 1 by 2 plus 6 into 1 by 4. So E of x is 4. E of y is equal to 1 into 1 by 2 plus 3 into 1 by 3 plus 9 into 1 by 6. So E of y is equal to 3. E of xy is equal to summation x into y into f of x comma y. So for that you have to refer the given joint probability distribution table. So when x is 2 and when y is 1, you get 2 into 1, 2, 2 into 1 by 8, that will be 1 by 4, plus when x is 2 and when y is equal to 3, you get 6 by 24. 6 by 24 will be 1 by 4. Like that, if you continue, the last value will be when x is 6 and when y is 9, corresponding probability is 1 by 12. So 6 into 9, 54. 54 divided by 12. That will be 9 by 2. So if we calculate the value of E of xy, the value will be 12. Then covariance of x comma y will be equal to E of xy. E of xy here is 12 minus E of x into E of y. That is 4 into 3. So 12 minus 12, that's equal to 0. Then you have correlation of x and y, that's equal to rho of x comma y, which is equal to covariance of x comma y divided by sigma x into sigma y. You don't really have to calculate the values of sigma x and sigma y here because the value of covariance is already equal to 0. So covariance is 0. Now we can even say the conclusion that for x and y are independent random variables. Next thing which we calculate is if x and y are independent random variables. So in the question itself, they have mentioned that x and y are independent random variables. X takes the values 2, 5, 7 with the probability 1 by 2, 1 by 4, 1 by 4 respectively. Y takes the values 3, 4 and 5 with the probability 1 by 3, 1 by 3 and 1 by 3. Find the joint probability distribution of x and y. Show that the covariance of x and y is equal to 0. Find the probability distribution of z equal to x plus y. So now here they have given you the marginal probability distribution. Not really, you will have to make them. So x takes the values 2, 5, 7, write them, and they have given you the corresponding probabilities, that is f of x. When x takes the value 2, corresponding probability is 1 by 2. So write that. For 5 it is 1 by 4, for 7 it is 1 by 4. Then for y, the values taken by y are 3, 4, 5. Corresponding probabilities are all 1 by 3. Now using this, you will have to make the joint probability distribution table. So how to do that? What we have to do here is, we have to note this observation. That is, they have given that x and y are independent random variables. If x and y are independent random variables, how do you calculate the value of covariance? It will be E of xy, and E of xy will be equal to E of x into E of y. So we can say that if you want to find the corresponding probability here when x is equal to 2 and for y is equal to 3, what we do is we take this value when x is equal to 2 and we multiply it with the value when y takes the value 3. So the value here is 1 by 2 into 1 by 3, that is 1 by 6. Next you have 1 by 2, that is when x is 2 and when y is 4, you get 1 by 2 into 1 by 3, again it is 1 by 6. Then when x is 1 by 2 and when x takes a value 2 and when y takes a value 5, you get 1 by 2 into 1 by 3. So you can see the value here is 1 by 6. So if you add up the values here, you get 1 by 6 plus 1 by 6 plus 1 by 6, that is 3 by 6. 3 by 6 is 1 by 2. Next, when x is equal to 5, these are the different values taken by y. So when x is 5 and when y is equal to 3, that is for this entry over here, we have to multiply 1 by 4 with 1 by 3. So you get 1 by 12. Then again for 1 by 4 and 1 by 3, so we get 1 by 12. Then we get 1 by 12 again here. So what do I get here? 3 by 12. 3 by 12 is 1 by 4. Next I have when x is 7, that is 1 by 4. 1 by 4 multiplied with 1 by 3. Then 1 by 4 again multiplied with 1 by 3. Again the same thing. So here I get 1 by 12. Then I get 1 by 12 and 1 by 12. So if you add up the values here, you get 3 by 12. 3 by 12 is equal to 1 by 4. Now let's add the entries over here, or let's calculate the column sum. 1 by 12 plus 1 by 12, that is equal to 2 by 12. 2 by 12 is 1 by 6. 1 by 6 plus 1 by 6. 1 by 6 plus 1 by 6 will be equal to 2 by 6, or it is 1 by 3. And here if you calculate the value again, you get 1 by 3. And if you calculate the value here, obviously we'll be getting 1 by 3 again. Now you can see that if you find these, or if you add these 3 entries here, or if you add these 3 entries here, the sum will be definitely be equal to 1. Now after this, what we can calculate is the covariance of x comma y, which is equal to expectation of xy minus expectation of x into expectation of y. So expectation of x is equal to summation x into f of x. So use this marginal probability distribution and calculate the value of e of x. Then e of y is equal to summation y into g of y. So using this table, calculate the value of e of y, that's equal to 4. Then you have e of x comma y, or e of xy, that's equal to summation x into y into f of xy, that's equal to, use this table and calculate the value, it will be equal to 16. Then covariance will be equal to 16 minus 16, which is equal to 0. We can directly write that the covariance is equal to 0, because in the question itself they have mentioned that the given two random variables x and y are independent. Now what we calculate here is the probability that z takes the value x plus y. So now here, this is the joint distribution table over here. Using this, we have to calculate the value of p of z for the value of z, where z is equal to x plus y. So now here, the values which z can take is, z should be equal to x plus y. So start adding the random variable x with the random variables y. So the first value which z can take is 2 plus 3, that is 5. Then after that, the next value which z can take is 2 plus 4, which is 6. Then you have 2 plus 5, 7. Then you have 5 plus 3, 8. 5 plus 4, 9. 5 plus 5, 10. 7 plus 3, 10. 7 plus 4, 11. And 7 plus 5, 12. So these are all the values which z can take. Please note, for 10 you have two different cases. So you have to consider both the probabilities, because z can take the value 10 when x takes a value 5 and when y takes a value 5. So 5 comma 5, corresponding probability is here 1 by 12. And it is also possible when x takes a value 7 and when y takes a value 3, and the corresponding probability is 1 by 12. So only for this case you have two different probabilities. So you have to add both of them and write the corresponding probability. Now first case, that is when z takes a value 5. What is the corresponding probability? That is this case, 2 plus 3. What is the corresponding probability here? That is 1 by 6. So write that here. Then for 6, it is possible when x takes a value 2 and when y takes a value 4. Corresponding probability is 1 by 6. Then for 7, it is 2 plus 5. Again it is 1 by 6. Then for 8, it is 5 plus 3, which is 1 by 12. For 9, 5 plus 4, that is again 1 by 12. Then for 10, I have told earlier itself that we have to take two cases. That is, one case is 5, 5. The corresponding probability is 1 by 12. And another case is 7 and 3. 7 plus 3 is 10. So you have to take two cases, that is 1 by 12 plus 1 by 12. That is 2 by 12 or 1 by 6. So the value here will be 1 by 12. This is from 5, 5 and 1 by 12 again. This is from 7, 3. So the corresponding probability here will be 2 by 12. 2 by 12 is 1 by 6. Now let's see the value for 11 and for 12. 7 plus 4, it is 1 by 12. 7 plus 5, for 12 again it is 1 by 12. So the value here is 1 by 12 and 1 by 12. So let's see the summation here. 1 by 6 plus 1 by 6 will be 2 by 6, 3 by 6. Then you have, so you get 3 by 6. 3 by 6 is 1 by 2. Plus you have 1 by 12. Actually, you can add this value also. So you get summation P of Z here will be 1 by 6 plus 1 by 6 plus 1 by 6. Again, you have 1 by 6. So you have 4 copies of 1 by 6. So you get 4 by 6. Plus you get 1 by 12 plus 1 by 12. That is, I'm so sorry, this must be 1 by 12 here. Then you have 1 by 12 plus 1 by 12. 1 by 12 plus 1 by 12. So you have 4 copies of 1 by 12 also. So if you add them, you get 4 by 6 is equal to 2 by 3 plus 4 by 12 is 1 by 3. So if you add them, you get the sum as 1. So summation of P of Z is equal to 1.